Welcome students. In the previous class we actually revised the chapters that is matter, force friction and also simple machines. Okay. Today we are going to discuss and also revise the rest two chapters that is light and magnetism. Okay. So this is a very fast quick revision on these two chapters. Okay. So first is light. Okay, what is light? Actually we can say that light is a form of energy that helps us to see any objects. Okay, and also we can tell that we need light to see the whole world, okay, around us. Okay, so it is a form of energy. And in generally, what are the sources of light? Actually, what are the sources of light? In generally, sources of light, it can divided into two segments. One luminous object, and the another thing is non-luminous object. Okay, and what is the difference between luminous and non-luminous object? Okay, you can say that in generally luminous means actually the objects that emit light, okay, of their own, that is called luminous objects. Whereas if you think about non-luminous objects, actually the objects that do not emit light of their own are called non-luminous objects. So if you think about luminous objects, then you can take as some examples like candlelight, torchlight, LED. Okay, so that means LED, candlelight, torchlight, etc. These are the examples of luminous objects. Whereas if you think about non-luminous objects, you can take as book, stone, etc. Book, stone, and etc. So this is the difference between luminous and non-luminous objects. Now in generally also you can think about some examples like firefly. Okay, so firefly is a, also you can say, luminous. Okay, it is actually basically you can take as luminous objects also. Okay, now the question is how we can classify different types of material with the help of actually, or with the help of ability of light to pass through. Okay, so this is actually divided into three materials. You can take as three materials. One is transparent, and the second one is translucent, and the third one, that is opaque material. Opaque material. Now what is the actually differences between three materials? Simply you can say for transparent material, okay, materials that allow light to pass through them completely are known as transparent, like clear glass, clear water, and also you can take a cellophane paper. Okay, these are the examples of transparent material. And if you think about translucent material, then you can say that materials that do not allow the whole light, or that or you can say materials that allow light to pass through them partially are known as translucent, like ground glass, okay, frosted glass, butter paper, vinyl fabric. These are the examples of translucent material. And what do you mean by opaque material? Simply you can take as materials that do not allow any type of light to pass through them is called opaque material, like wood, cardboard, okay, thick cloth, metal, leather, okay. These are the some plastics, okay. These are the examples of opaque material also. Now the question is actually how we can actually classify different types of light or rays. Simply you can say actually rays and beams of light, rays and beams. What is the definition of rays? In generally you can take as that a very fine or narrow path of light is called rays. Whereas what is the definition of beams? Actually a collection of rays of light is called a beam of light. So this is the difference. And also you can take as beams are classified into different segments. If you first you take parallel, okay, parallel beam of light, and the second one you can take as divergent beam of light, and the third one, that is convergent beam of light, okay. So the light parallel beam of light means this type of actually beam of light. For divergent you can take like this is the actually diagram of divergent, and convergent like this, okay. So this is actually convergent beam of light. Now what do you mean by rectilinear propagation of light? Okay, simply you can say that in generally what is, this is very important properties of light also. You can take rectilinear propagation of light. What is the definition of rectilinear propagation of light? In generally you can take as simply that light travels in straight lines as long as it is traveling in the same medium. This property is called rectilinear propagation of light, okay. With the help of these properties we can actually take some applications of rectilinear propagation of light, like first one you can take as shadow, okay. In generally shadows form because of rectilinear propagation of light. Second, you can take as day and night occurs because of the fact, okay, day and night, day and night. And the third one you can say eclipses. Eclipses occurs due to rectilinear propagation of light. And the fourth one is you can say pinhole camera. Pinhole camera. So here we just discuss about all the things. First one, if we think about pinhole camera, okay, pinhole camera. Actually, a pinhole camera is a very simple device that is used to take photographs, okay, of stationary objects, and it works on the principle of rectilinear propagation of light. And with the help of pinhole camera, we get image, okay, of an stationary object. And what is the nature of the image that is formed by pinhole camera? Simply you can take as image is real, and the second one is it is inverted also. And you can take as the image is real, that means image is formed on a screen also. And what is the size of the image? It depends upon the distance between screen and object, and also you can take as screen and actually, or you can take as the distance between object and source also. So this is the simple uh, working principle on pinhole camera. And the next one, that is shadow. For shadow, you can take the conditions for formation of a shadow, that is a source of light, an opaque object to obstruct the path of light, and the third one is an opaque screen to obtain the shadow. And you can take as some characteristics of a shadow. Okay, these are, you can take a shadow is always a dark area. It does not show the color of any object. And the second one is a shadow may or may not look like the actual shape of the objects. And the third one is the size of a shadow depends on the distance of the object from the source of the light and screen. And the fourth one, you can take as a shadow can only be formed on a screen. And here you can get 2 points, very important point, that is umbra, and the second one is actually penumbra. Okay, and what is the definition of umbra and penumbra? You can take as for umbra, a shadow generally consists of two regions, a central dark, that is called umbra region, and the outer less dark region is called penumbra region. Okay, and here also very important things are a point source and extended source of light. Okay, point source and extended source of light. And what is the difference between point and extended source of light? That is also very important. So in generally, for point source, you can take as any source of light that has a negligible extent is called a point source of light. Whereas if you think about an extended source of light, an extended source of light possesses an extent or radius. Okay, so and also we move our next topic, that is you can think about eclipses also here. Okay, there are total two types of eclipses. Okay, one thing is solar eclipses, and second one is actually lunar eclipses. Okay, when solar eclipses occur, in generally when moon is coming in between earth and sun. Okay, then we get solar eclipses. And in generally solar eclipses can occur only on a new moon day. Whereas if you think about lunar eclipses, you can take as when earth is placed or earth is coming in between moon and the sun, then we get lunar eclipses. And here you can take as we can find out lunar eclipses in a on a full moon day. Okay, so this is basically actually short revision on light. Now we move our next part, that is magnetism. Okay, simply you can take as for magnetism, first one you have to know about what do you mean by magnetism. Okay, in generally, a magnet is a substance that can attract objects made of iron, nickel, cobalt or their alloys. Okay, The property of a magnet or to attract such objects is called magnetism. That means here we have to know about magnetic and non-magnetic material also. Okay, magnetic and non-magnetic material. And what do you mean by magnetic and non-magnetic materials? In generally magnetic substance that get attracted by a magnet also easily. Okay, and the examples are magnetic materials, iron, nickel, cobalt, or their alloys. Whereas non-magnetic material means you can take, they are not attracted by a magnet. Okay, like plastic, wood, paper, rubbers, these are the examples of non-magnetic substances. And the next thing is actually natural, and you can take natural and artificial magnets. Okay, naturally occurring rocks such as lodestone or magnetite. It is basically uh, actually it have the ability of attracting magnetic substance, and hence they are called natural magnets. Okay, and artificial means magnets that are made by humans are called artificial magnets. Now, what are the properties actually? What are the properties of magnet? Properties of magnet. Simply you can take as, first of all, you can take that first property is, you can take attractive property. Okay, and the second one is actually poles of a magnet. In generally magnets have two poles, one is north and another one is south pole. And attractive property means always north pole attracts south pole. Okay, and also you can take as that magnets attracts magnetic substance also. And the third one is that is directive property. In this case you can take as a freely suspended magnet always points in the geographical north south direction also. And the last one is magnetic poles exist in pairs. Okay, so we cannot get magnetic poles in actually we cannot get any single pole. Okay, in generally always we get magnetic poles exist in pairs. Okay, now what is the test for a magnet? Okay, attraction or repulsion, you can take as repulsion. Okay, so this is very important. Repulsion is the surest test of magnetic or magnet, any magnet. And you can take as for a bar magnet some, if you think about, this is a bar magnet, different types of magnets, the different size or shape of magnet we have. In generally if we think about bar magnet, then this is north pole and this is south pole, and this point is the midpoint if we name O. Okay, so here you can take as N is the magnetic north pole and S is the magnetic south pole. And if we connect north pole to south pole with an imaginary line like this, and this line if you name as X and Y, okay, this is magnetic axis. That means the imaginary line XY passing through magnetic north pole and magnetic south pole of a bar magnet is called magnetic axis. And the next one is actually magnetic equator. What do you mean by equator? An imaginary line that is, suppose PQ, okay, that is passing through O point, and also you can take as this line PQ bisecting the effective length of a magnet is called magnetic equator. So PQ is the magnetic equator, whereas XY is the magnetic axis. And what is the effective length? You can take as The distance between North Pole and South Pole is called effective length. Okay, here also we just move our next point, that is magnetic field. Okay, what do you mean by magnetic field? What do you mean by magnetic field? In generally, you can take as, if we actually take a magnet, the force exerted by a magnet is called simple magnetic force. Okay, and around any magnet there are some imaginary lines. Okay, the imaginary lines are called magnetic field. Okay, and the strength of the magnetic field of a magnet decreases when we move away from it, and magnetic field is represented using curved lines are called magnetic lines of force. And also we have to know about some properties of magnetic lines of force, like first one is magnetic lines of force are continuous curves, second one is outside a magnet the magnetic lines of force begin from north pole and ends to its south pole. However, inside the magnet their directions is formed from south pole to north pole. And also you can take as no two lines of force ever intersect at a point. Okay, and the fourth one, densely populated lines of force indicate a strong magnetic field, whereas widely distributed lines of force indicates weak magnetic field. And fifth one is, you can take magnetic lines of force show the direction of magnetic field at each point around any magnet. Okay, and also you can take as earth behaves like a magnet. Okay, that means earth as a magnet also. Okay, and here you just remember, when a fully suspended magnet always come to rest in the north south direction. Okay, this is because due to earth behaves like a huge bar magnet. Okay, and also there are two axes, one is simple geographical axis and another one is magnetic axis, and the difference between geographic and magnetic axis is around 11 degree. Okay, and here also two important things, that is you can take as temporary magnet, and also first one is temporary and permanent magnets. Okay, actually temporary magnets mean magnets that retain their magnetic properties for a short duration of time are called temporary magnets, whereas permanent means actually permanent magnets have strong magnetic field, and also you can take that the magnetic properties remains permanently. And for permanent magnet, it is in generally made of some iron, steel, copper, nickel, or any alloy like alnico. Okay, alnico is a mixture of aluminium, nickel, and cobalt. This is very important. Okay, and you can take as some magnetizing method, like first one is you can take as single touch method, double touch method. Okay, and also you can think about magnetizing by induction also. And what is electromagnet? Already that is discussed. Electromagnet is a temporary magnet. Okay, in this case we use actually current. Without any electricity we cannot get any type of magnetization or magnetic property. Okay, in generally electric current can also used to make magnets. If a coil of insulated wire is wound around a piece of magnetic insulated substance and electric current is passed through them, then we get actually a power magnet, temporary power magnet, and it is called electromagnet. And we can easily change the strength of electromagnet by actually increasing or decreasing current. Okay, and also we can use by actually changing the number of turns of coil. Okay, and in generally in the core we just use soft iron because iron does not retain its magnetism once, okay, when current is switched off. That is why we can use soft iron as a core material of an electromagnet. And also you can actually we have to uh, remember the difference between permanent magnets and or electromagnets also. Okay, for permanent magnet you cannot change the pole, okay, but for electromagnet we can change the actually direction of pole also. And strength cannot be changed for a permanent magnet, but for electromagnet we can change the strength of magnetic field also. Okay, and also we have to remember some uses of magnets. Okay, in generally uses of magnets are there. There are several numbers of uses like in magnetic compass, okay, computer, television, speaker, microphone, ATM cards, credit cards, okay, uh, and etc. Okay, these are the uses of magnets. And some we have to remember some demagnetizing actually methods like we can if rough handling, okay, dropping the magnet on the floor several times, hammering the magnet several times, okay, passing AC current through any magnet, okay, heating with a very high temperature. So these are the actually methods or ways by which we can get demagnetization. Okay, and also we have to take care and storage of magnet. Okay, and also self demagnetization. In generally we use magnetic keepers to store or care any magnet. Okay, so in this way we just complete the whole chapter. Okay.